Hello, Martin here. This is another video about Universal Radio Hacker. This is a follow-up to previous video where I used this 433 MHz module and to control this radio plugs. You don't always need these modules. It is also possible to use some other radio modules. For example, I have this hardware from Big Clown which has ST SPIRIT1, which is sub-1 GHz transceiver. This chip can be flexibly configured to different modulations and data formats, and you can also transmit your own data, not only the specific formatted packets. And I wanted to use this hardware and try to configure it so it will react it will control the RF plugs. This radio module has few modulation schemes, so you have to choose on-off keying modulation. And this, of course, this doesn't apply just to the ST SPIRIT1 radio. A lot of other manufacturers does these radios, and you have to configure them right. Then there's the packet handler engine, which means how the data in your FIFO, in your buffer in the radio are formatted. There are three formats which are for some remote metering reading of the water utility meters and devices like that. So here are some for some packets, but when you look at the radio packet which this remote control sends, then there is no preamble, there is just the binary data immediately. So this is not suitable for our usage. You can disable the sync. You can set 1 byte for sync, but the sync bit distracts the communication, and the RF plug doesn't respond to that. And preamble is also fixed, is this binary pattern, binary sequence. So the stack packet is not usable for us. Then there is MBus packet, which also has preamble and sync words. And the last one, the basic packet, was the closest to the format you would like to have. But I had an issue with the preamble because the minimum preamble is 1 byte. So on radio layer it always sent this binary sequence, which destroyed the receiving, the communication. And then there was also the minimal sync length is 1 again. So I could disable length, address, I could disable control. So I used only payload. I also disabled CRC because 0 means you can disable it, but I couldn't disable the preamble and sync. And then later I've discovered another feature, which is this data mode, and it is possible to disable normal mode and switch to direct FIFO, which means the chip sends anything which is in the FIFO. So this is very good to send any format, any packet you would like. On the receiving side, this will be a little bit more difficult, but I'm not using receiving. I'm just sending data from the module to the RF plug. So if we take a look on the code, which is using ST SPIRIT1 library from ST Microelectronics. So there's basically something to debug. This is using Big Clown SDK. So I initialize logging over serial LED, which will blink when I press the button, and the button itself. And this callback is called when I press the button. Then the most important thing is in it the radio and the communication. And here is the structure which is sent to the radio, and it consists of these defines, and the most important is the frequency, which you measure in Universal Radio Hacker in the spectrum analyzer. You can see that on the previous video. Then channel space, I I don't know what should be here exactly, so I kept it here. Channel number is 0 because we would like to transmit on this specific frequency. So when I put any other number here, then the frequency gets shifted by this amount of hertz. Then there is a few possibilities of modulations, so I choose on-off keying. And the data rate. The data rate is important to have right, and it's the number you which was auto-detected or which is manually selected. This is close to 700 microseconds. So if you delete 1 second by 700 microseconds, you get this number, which is a baud rate, and you set it to the chip. And there's another numbers which I don't understand yet. So when you press the button, the command is sent 4 times. This is because the transmitter really sent it 4 times, but it is not necessary. And I add 100 millisecond delay every time. And so this RF command is sending the bucket. Now let's take a look how to set the data correctly. So after this is this first scope display is the transmitter, and this second one is my Big-Clown core module, which I will get later. So after the modulation, you can see this data, and basically I take these bytes, and you have to reformat them. So 96 4B is here, so you just add hex prefix 96 4B and you copy the whole packet here, which is ending C8. This 0 really is here because some error. It doesn't matter if you put it here or not on the end. So I call this RF command, send RF command with the packet and the length, and this command does just a few things. Clears the FIFO. This is important. It sets the direct TX FIFO mode, which is this direct FIFO mode. So I wouldn't get any prefix, any sync word, and so on. Then set the data length and write the data to the ST Spirit module FIFO, internal FIFO. And this is the last command which sends the data. This module is tuned to 868 MHz, but I was lucky enough to desolder this tiny antenna from the chip, and I've added a wire which is about 30 something centimeters long, which is the right length to 433 MHz, and I also set 433 MHz here. So this is not ideal because in the chip there are some filters, and these two parts also are part of the filter. But this works really reliably for 10 meters at least. So yeah, this is just the hacking, just playing with this. So I compile this example, and I flash this, and it gets flashed to the core module. So right now I can control the RF plug with original remote. And when I press this button, then I can control it with a button. And if I record the signal from core module to my RTL-SDR and then set a ASK or a demodulation, then I can see that the command exactly aligns. You can use also analysis, and you can mark as a reference message, which is the first one, the original I've sent with this remote, and this second one, which is this record, is from the data from core module, and then when you select text and mark diffs in the protocol, you can see that the data are the same. I'm not sure, I'm also transmitting 1 byte more. I'm not sure what's happening in the ST Spirit chip, but as you can see, it really doesn't matter. So I ignore this behavior right now. So I hope this video explained a little bit more how to use Universal Radio Hacker practically together with some radio transmitting hardware, and it would be great if you share this video or give it the thumbs up, because that's what motivates me to create more content. So see you next time. Goodbye.